whatever. So
yeah. Yes. Clicked on
fantastic.
recording. So we are recording now. Over to you, Tim.
Thank you very much, Amit. And welcome everyone to Data Engineering Melbourne. This is the first gathering or meeting for 2022. And we're really excited tonight to have some people from Castled, Arun and Franklin sharing with us, which is going to be really exciting. After the talk, we're going to follow our normal format for Data Engineering Melbourne, and we're going to have a community marketplace. So we'll talk a little bit about that after the presentation and stuff. But without further ado, I think we should jump into it and hand over control. And thank Arun and Franklin for talking to us a bit about Castled and Reverse ETL.
Cool. Thanks, Tim. I mean, for inviting us. Thanks all for hosting us. I mean, that really means a lot. Okay, so my name is Arun. I'm one of the co-founders of Castled Data. Right, I have around 10+ years of experience in the software industry and around 4 years of experience in the data space. Yeah, I mean, that's about it. I mean, actually, I have with me my co-founder Franklin as well, right? So I'll let him introduce himself.
So hi everyone. First of all, thanks for having us. So my name is Franklin. So I am also one of the co-founders of Castled. So prior to Castled, I was a file system engineer at Nimble Storage. The company got acquired by HP a few years before. So most of my experience has been in the data storage industry, and so overall, similar to Arun, I have almost 10+ years of experience in the software engineering industry. Back to you, Arun.
Yeah, actually, I think to share my screen, I have to just restart my browser. I'm really sorry about that. Can you just I'll come back in a minute? Is it okay?
Yeah,
Sure, that should be okay.
Yeah, sure.
It says you should have presenter rights, I think.
No, I think I have to change. I mean, I have to set that into my browser, I guess. I'll just join in just a second.
Okay, sure. How about you, Franklin? Can you see a button that says share screen?
Let me try. So I think it looks like a Zoom permission thing. I have to kind of enable, add permission for Zoom to kind of record my screen. So that would mean I have to restart my browser as well.
Oh, right. Okay. Sure. So if you're not a regular Zoom user and you're new to Zoom, it might ask for some permission, perhaps.
Yeah, I think I changed my laptop recently. I got a new one. Probably this is the first time I'm sharing my laptop. I mean, sharing my screen. Okay. With Zoom after.
Sure.
Sorry about that. Just give me a minute.
Sure. We might see how Arun goes when he rejoins and see if it then works for him and if he's able to share. And whilst he's presenting, that might give you an opportunity to do a restart as well.
Sure.
Oh, wow.
We can see your Slack.
Yep, we can see your screen, Arun. But we can't hear you.
Can you
now
hear
we can.
me?
Yes.
Sure. Yeah, sorry for that. Yeah. Okay, so without further delay, I'll just start, right? So this talk, we have structured that into 3 different segments, right? In the first segment, I'll be taking you through reverse ETL and the modern data stack and how kind of everything fits together. In the second segment, Franklin will kind of take you through the demo of the product demo, right? I mean, where you'll be able to see reverse ETL in action. In the third segment, we can do a brief, code walkthrough about of Castle. I mean, not the full thing. I mean, it's just about how we can easily build a connector in Castle, especially since we are open source, right? So that's how we have structured the talk, right? We can have a small Q&A in between every segment, so that there is not like a lot of information overload coming your way, right? Yeah. Okay. So I'll just start, right? So yeah. Okay. So basically, like I mentioned earlier, in the first segment, we'll be explaining reverse ETL, the modern data stack, and everything else, right? So before that, I would like to spend some time talking about what triggered the creation of the modern data stack, right? I mean, what kind of triggered this kind of data revolution, which people are talking about, right? And so that is the evolution of cloud data warehouses, right? I hope that at least some of you remember that at least 10 years back, we had this traditional on-prem data warehouses, which was extremely expensive. You need like a big data team to maintain it. It was expensive. It was not scalable. If you want to if you want to scale it up or scale it down, you have to take a downtime and then you have to like add nodes, right? I mean, it was extremely like not at all scalable. It was, and again, like not everybody had the privilege to kind of do data analysis because it was, I mean, it was not easy, that you cannot have data analysis from day one because you need to kind of scale up, build a data team, and then build an infra team, right? And then you can kind of do data analysis, right? Which is not really an ideal view for most of the small to medium scale companies, right? So then everything changed when Amazon Redshift released their first cloud data warehouse in 2013, right? So then everybody, it is just, you can sign up and you can have your data analyzed like within a few hours, right? You can have all the data from your different data silos moving to the data warehouse, and then you can, you know, like use some kind of dashboarding system like Tableau or Power BI on top of your Redshift, and then you can have all this reporting on the charts and everything. I mean, everything is ready, right? I mean, that was kind of quite a major change in the data space, right? So suddenly every organization had access to analyze the data at an affordable cost. I mean, it was kind of pretty straightforward, right? So now they started getting a lot of traction. A lot of customers realized the value of the cloud data warehouses, started moving there. But very soon, right? I think within a few years, people started getting a lot of other bottlenecks, right? Because Redshift is what I would term as like a first generation cloud data warehouse, because the architecture is kind of a legacy kind of an architecture, which involves, I mean, basically they had, you know, kind of modeled it on like a Hadoop kind of a system where your data and your compute is co-located within the same node, right? I mean, obviously it is supposed to make it faster, right? But that introduced a lot of other bottlenecks. For instance, so if you want to scale compute, right, you have to scale, like, you know, you basically want to kind of throw more hardware at compute, right? Maybe you want to kind of give more resources to your ML models. If you want to do all those things, you have to scale your storage as well, right? And vice versa. If you want to scale your data, then you'll have to scale your compute resources as well, right? Because everything was co-located within the same node, right? And also the scaling up again was becoming problem, right? Because it was, you cannot like scale up by clicking a button. You have to kind of take a downtime, like small downtime, and then do it. Then you have to do vacuums, like manual, you have to do manual vacuums. So right now they have fixed it, but I mean, there are a lot of, you know, problems which Redshift was facing. And then these so-called modern data warehouses came into existence, which was like BigQuery and Snowflake, right? Which kind of solve this problem by separating out your compute and storage. Right, so here you can store the data in Snowflake and probably store the data in S3 and have some query engine running somewhere else. We can just, you know, scan the data on S3 and, you know, do whatever computation you want. Similarly, in BigQuery, you can have the storage and you can have your ML query engines, you know, query the data, right? So this kind of solved most of the problems in the cloud data warehouse. Right, it was very easy to kind of scale up, scale down, right? I mean, everything became pretty, but kind of seamless, I would say. Yeah, so even now, a lot of research is being done in the data warehouse space. New data warehouses like Firebolt is coming up. Even Databricks is doing a lot of research on data lakes by introducing Delta Lakes, data lake warehouse, right? I mean, so I want to kind of go deep into that because I don't know how those, I mean, these are, I would say, as in a kind of maturing state, right? I mean, in a short while, we'll know how those shape up, right? Yeah, so this is about, you know, the cloud data warehouses. Okay, so now coming to the main point, right? The modern data stack, right? Once the cloud data warehouse started becoming popular, everybody realized that is where all your data, right? I mean, your data which is in different data silos. So when I say data silos, your your sales team has a different view of your user. Your marketing team has a different view of your user, right? Your tech team has a different view of your user, right? So now this data, right? Your user, product, business data is lying in different data silos, right? So now everybody started moving the data from these data silos back to your cloud data warehouse, right? So that became the common infra for every modern data-driven company, right? So here, if you see the diagram here, you can say about the events, right, which is on your mobile apps or your website apps, right? So those events are being fed to a data warehouse. Similarly, your MySQL database, Postgres database, your MongoDB, right? SQL, NoSQL databases, right? So those are also extracted and loaded to your data warehouse by the different ETL providers, right? Similarly, the data from your different operational tools like Salesforce, HubSpot, MailChimp, Zendesk, Intercom, those are also started flowing in your cloud data warehouse. And very soon your cloud data warehouse started getting the 360-degree view of your customer, of your lead, of your product, of your business, right? So data warehouse became the place where everybody used to kind of dump all their data. And then obviously all your ML models and all the transformations used to kind of run on those. And then the transform data or the transform insights are started, being fed into this dashboarding, into these reporting tools like Tableau, Power BI and all, right? So that's kind of the modern data stack, right? So you can see DBT here. DBT is an essential part of the modern data stack because we are not doing ETL now, we are doing ELT, right? So we kind of load the data and then do transformation there. And of that transformation, if you're talking about EL and T, right? E and L is actually solved by a lot of like ETL providers like Fivetran, Matillion. I think Matillion is quite popular in Australia. And so these guys have solved the load part, and DBT has been solving the transformation part for quite a while. It is an integral part of your modern data stack, right? So if you consider the modern data stack, this is how it looks like. You have an ETL, you have a cloud data warehouse, right? You have DBT, and then you have your reporting tools, right? So this is the basic infra. This doesn't complete the whole thing, but this is the basic infra that everybody should have to kind of do some kind of data analysis of your organization. Right. Okay, so now everything is well and good, right? So you have data flowing into your data warehouses, and then you have reporting tools on top of that, and your business leaders are getting the data, right? The valuable insights, so they know what is stopping their business, what is going well, what is not going well, what is going wrong, right? So what are the things that they can do to kind of fix the problems, right? So using kind of these kind of reports, they were able to kind of figure out the short-term, mid-term, long-term roadmaps, right? Based on which you can like kind of transform the company, right? So everything was going well, right? So now, what about your operational tools, right? So now, like it is not only this data which is being fed in the data warehouse; it was just used for this reporting purposes, right? But if you imagine, this data is extremely powerful, right? Because your cloud data warehouse is the only you can place in your entire organization, which has a 360-degree view of everything. It has all the data. It has all the insights. It has even the insights which is kind of generated by your ML models, right? So now, so what about the other business functions of an organization who are handling day-to-day operations of your organizations? For instance, your sales team, your marketing team, your support team, right? So all these, if you consider like a midterm organization, use around 40 such SaaS apps, right? So Castled is starting up. We are already using 7 to 8 such tools, right? So it is estimated that a mid-scale organization uses around 40 such tools, right? So now these tools are extremely powerful in the functionality they provide, right? So there is no doubt about the fact that these are extremely powerful, but are they getting the data, right, which kind of helps them make the right decisions, right? For instance, your is your Salesforce, right, getting the lead scores from like basically using which your sales person can go after the right set of leads, right? So you get say 1 million leads from somewhere, right? Your sales team will not be able to kind of talk to everybody, right? He needs to figure out okay, these are the 100 most significant users and or most users who are going to convert, and maybe I should be going after them, right? So now, is this data being fed into these tools, right? All these guys require user data, product data, right? Is this actually being fed into the tools? So to figure that out, we talked to some of these companies who already have a data warehouse and ETL, right? So some of the ways in which this data, obviously everybody has to kind of feed this data to these tools, right? But how is the data being fed, right? So first way is, like you do kind of unreliable and manual CSV uploads, right? You kind of create an Excel sheet and then you upload it in these tools, and then then the data can go in. This is manual. It is totally unreliable. It causes data quality issues, data duplications, data corruptness, right? So it is not, I mean, you cannot rely on this data. It kind of works, but not like perfectly. You cannot rely on it, right? So now some of the more advanced businesses, right, who have realized that it cannot be manual, it needs to be automated, right? So they have created some kind of a data loop by doing point-to-point data transfer between the SaaS apps, right? For instance, so they have Salesforce, they have HubSpot, they have Intercom, right? So the data from the Salesforce is directly fed into HubSpot using tools like Zapier, MuleSoft, right? And again, the data from the HubSpot is fed to tools like Intercom, right? There are a lot of, I mean, if you see how it looks like, right? So this is how actually one of our customers actually even drew this for me. This is how this looks like, right? I mean, if you see Intercom is the data from this HubSpot is being fed to Intercom. From Intercom, it is fed to Mixpanel. From Mixpanel, it is fed to Google Ads, right? So it's kind of a data mesh, right? You have to kind of maintain this entire thing to make sure that the data is being fed into all these tools, right? So even if you have maintained all this entire data loop, right, you are not still getting the data which matters, right? For instance, if you're moving the data from Salesforce to HubSpot, right? Salesforce just has a 10% view of your customer, right? So that 10% data is going there, right? So now Google Ads has, you know, some kind of data that we have run some kind of campaigns there, and this particular user has clicked on that, right? So that data is there in Google Ads, right? You can move that data also to HubSpot, right? But this raw data which is coming to HubSpot, right? There's no way in that we can kind of go to HubSpot and, you know, kind of merge them together and have some kind of insights on top of that, right? Because HubSpot is not meant for any kind of data analysis, right? So that is the problem, right? You have to maintain this extreme kind of a data loop, right? But still you're not getting the data which matters, right? The problem is the source of your data. The problem is not automation. The problem is the source of the data, right? So the data needs on these operational tools ideally should be coming from the cloud data warehouse, because cloud data warehouse is the place which contains that like 360-degree view of your user or a product, right? So now you have to kind of remove all this data mesh or data loops and then put in like a simple thing that you have to feed all your operational tools by considering your cloud data warehouse as your single source of truth, right? So that is what is the current problem with this thing, and that is why that is exactly the problem what Reverse ETL is solving, right? So now if you like, I have just changed the image which you saw 2 slides before to include Reverse ETL, right? So now the events are being fed to cloud data warehouse. The DBT is doing transformations. There are ML models being run on the data warehouse, which is doing some kind of transformation and generating some insights. And these insights, right, are being fed from the cloud data warehouse back to these tools, right? So that is Reverse ETL, right? If you see, there is no other point-to-point integrations, right? All these tools like Zapier, MuleSoft ideally should, like at least in the modern data stack, there's no place for that. I mean, you can still solve some use cases with that, but I mean, I would not really consider that. I mean, that's not the ideal view. Okay, so that is one of the reasons why Reverse ETL, because if you see like hundreds of modern data-driven organizations have already removed all their data meshes or data loops, right? I think data mesh is a confusing word, but data loops, and then they have started putting Reverse ETL instead, right? Just keep very simple: ETL, data warehouse, Reverse ETL, ETL. So it's ETL, you move the data to data warehouse, you do DBT transformation, and then the output of that goes back to their operational tools, right? So that is the modern data stack right now. Okay, so some Reverse ETL use cases, right? Like for instance, the sales team, it's the same use case which I talked about before, right? You can know your best customers within your sales CRM, right? You can actually know the lead score, right? You know that this particular customer has clicked on the pricing page, right? Or he has, you know, downloaded a guide from your application, right? So based on all these things, you can create a lead score, and the leads on the data warehouse, right? These events and every data is coming on the data warehouse, right? The data warehouse, you can obviously create a lead score by joining the data which is coming from multiple sources. And then this computed lead score can be transformed back to your Salesforce, so that your sales team knows who are your most important customers and whom they should go after, right? If they get a lead of like a list of 10,000 leads, right? They cannot go after everyone. They need to know that out of this 50 customers, these are the people with intent to convert, right? Again, similar thing with marketing, right? You can personalize your outreach and increase response rate by syncing the user behavior data into your tools. Let's say tools like MailChimp, right? I mean, So basically, you know that you can personalize your emails, right? By knowing the user behavior, you know that the user has done this, this, and that. And then you know that the user has attended, say, a webinar, right? So based on these things, you can even change the messaging in your marketing tools, right? Or you can even sync user data like LTV, right? Lifetime value of your customer. You can even, obviously, these can be computed only on data warehouse, because in that is where the data is, right? You can move this data, the LTV data, to your ads platform like Google Ads, LinkedIn Ads, and based on that, you can again figure out what is the right audience to target, right? Some more use cases, right? So support team, right? For instance, the support team uses intercom centers, right? And somebody raises support issue on intercom or centers, right? Now they need to know which issues to prioritize. For instance, say a customer is at the risk of churning, right? And based on the data on the data warehouse, we already figured out that this is the segment of users who are at risk. So if you move the data to your intercom or centers, your support team will know that, right? If somebody on that particular segment raises a support issue, they know that they have to fix this first, right? Because they are kind of at-risk customers, right? So that your support team can know what to prioritize. Again, one of the other interesting use cases that we have seen is notifications, right? Some of our customers, what they want to do is they want to run a query on your data warehouse, create a segment of users, and send like email notifications, SMS notifications to just the segment of users, right? So what they do is they try to move the data from data warehouse to like tools like Kafka, Google PubSub, right? From there, they can write consumers, we can read this data and send email notifications to their customers. Right, okay. So now the thing is, I mean, it looks like a data pipeline. Reverse ETL looks like a data pipeline solution, right? I mean, the only thing is your data warehouse is a source and your destination is like tools like Salesforce, HubSpot, Intercom, right? But ETL also is a data pipeline solution. It can do the reverse, right? It can move the data from Salesforce to a warehouse, right? So now why can't ETL solve this problem? So whenever we started building it, right, whomever we talk to, they're saying, I mean, why do you need a different category for this, right? I mean, ETL can solve this problem, right? You just hook a warehouse as a source and the Salesforce a destination, you're done, right? But it is not that simple, right? We have actually our founding engineers have worked on ETL solutions before. So we know that your cloud data warehouse is so powerful that it can change the entire architecture of the product based on which side of the pipeline your data warehouse is on. For instance, in the case of ETL, it is on it is the destination, and in case of reverse ETL, it's the source, right? But it actually changes the entire architecture of your product, right? So you cannot have the same product solve both of the problems reliably, right? If you're talking about if the keyword is reliability, you cannot really solve the problem both of them within the same product, right? So I'll explain some of the key challenges in a reverse ETL pipeline. First is, how do you compute deltas from a cloud data warehouse which does not contain the typical write ahead log, right? For instance, I think some of you know that ETL developers, right, they will know that if you want to say move the data from if you want to get deltas from your say MySQL or Postgres, right, you can always read the transaction logs, right, write ahead logs, using which you can just get the deltas and move the data to your data warehouse, right? And even in SaaS apps, you can have some kind of a modified timestamp which is kind of slightly accurate, right? So you can do all those things on ETL, right? But how do you kind of get deltas from a cloud data warehouse, right, which doesn't support transaction logs? If you depend on your updated timestamp, then that is going to be extremely inaccurate because of the long transaction windows in a cloud data warehouse, right? So that is one key challenge in a reverse ETL pipeline, which you will not find in an ETL solution, right? Handling rate limits on destination, right? In case of ETL, your destination is your cloud data warehouse, right, which doesn't really have a lot of restrictions, right? But in case of reverse ETL, your destination are tools like Salesforce, HubSpot. These are transactional systems, right? They have a lot of rate limits, right? They might say that like I cannot handle more than 1,000 requests per second, right? Or they might say that you can make like 15,000 API calls in 24 hours, right? So we'll have to take care of all these rate limits and handle them, right? So that the entire experience is seamless to the user, right? So that is another problem which is obviously not there in the ETL solution, right? Handling deduplication of records on destination APIs, right? So now say you have a contact object in HubSpot, and I say like Arun and Franklin are two records in HubSpot, and Arun is identified by my email, which is arun@castle.io, right? So now if the same record change in my data warehouse, I should want to take the data, just the delta, and update that in my HubSpot, right? So now how do I do that? Right? How do I make sure that I just upset the current record and not create a new entry for this thing, right? So that is also easy to do in ETL, because your cloud data warehouses, you can all run all these deduplication queries, right? You can have a timestamp, and based on that, you can run these deduplication queries. But because your destination is the Salesforce, you cannot do that. Right? Again, failure handling and automatic retries. What happens when you try to update it and fails, right? Because maybe there is some limitation there, or maybe the service is down, right? So when that happens, right, you have to make sure that whatever records failed, it needs to be retried on the subsequent pipeline run, right? How do you guarantee that, right? So all these problems are there, right? I mean, the last problem, I assume it's still there in ETL also, right? So now this is where the challenges, the assumptions that you can make in a reverse ETL is totally different because of these challenges, right? So that is the reason why ETL and reverse ETL has to be totally different products. Okay. Yeah. Okay. So I just want to explain. So we are a cloud solution, but we also have an open source solution which we are actively focusing on. Right. So the reason why we went the open source way is kind of pretty straightforward. Is that, like I told you, that the founding team had worked in an ETL solution before, right? So there, even in reverse ETL, right? If you want to have a look at the number of connectors that needs to be built, right? We are talking about tens of thousands of connectors, right? And we know that any closed source solution will not be able to support so much of connectors, right? For instance, if you see Fivetran, it has been there for 5 years. They have around 200 connectors, but eventually they have to build around 10,000 connectors, right? And every week or every day, like a new connectors are being added. So we know that obviously if it's a closed source solution, right, it will always be incomplete, right? Your customers will always say that I am using this particular SaaS app, right? Can you support it, right? But then they'll maybe you'll keep on getting this feature request, but you will not be able to support it, right? But in our case, we are open source, and also we have made a framework in such a way that, right, if somebody wants to write a new connector, right, they can do it within a day, right? We have kind of customized a framework in such a way that it is pretty easy to kind of write a new connector. Right. So that is one thing. Another thing, like I told you, that is you kind of give your flexibility for your users to write their own connectors, as well as, right, if you want to fix like minor bugs, you can do that yourself. Right. Normally in a ETL solution, you have to wait, you have to raise a request and even wait for weeks to kind of get some critical issues getting fixed on your production pipelines, right? So that will not be there if it's open source. Right. Other advantage that we see with open source, that we'll have more transparency about the security of your data, right? You can clearly see what we are doing, right? So that you'll not have any doubts about the security of your data, right? I mean, yeah, so that is one of the reasons, that's actually one of few of the reasons why we went the open source way. Right. Okay. So about Castled, so like I mentioned earlier, we are open source. This is our GitHub repo, right? I mean, please don't hesitate to show your support by starring our repo. If you want to run this application on your desktop, you should be able to run it within a minute. If you want to deploy it on premise, you can do that free of cost, right? We'll be supporting you there as well. Yeah, so do let us know. Yeah, and we are backed by Y Combinator, who has backed names like Fivetran, Segment, Airbyte, right? So we are fortunate enough that they've accepted us, right? And like I told you, founders comprise mostly early engineers from a very popular ETL solution. So we have seen all the customer struggles, right? We have seen what are the problems they normally face with a data pipeline solution, right? Yeah, so that's about the first segment, right? Before going to the demo, we will be open to take questions.
Thank you very much, Arun. That was a good history and leading to, how Castled, I suppose, came to be and what it's trying to do that's a little bit different to ETL and some of the other things. Was I the only person that asked a question? Did anyone else have any questions for Arun before we jump in and perhaps see a demo?
Yeah, I've got a question. So Arun, you were speaking about when, writing back, as it were, to these operational stores, you got to be aware of perhaps some limitations that may be in place. So, Salesforce API calls. Are there any other sort of like gotchas or, things like that when wanting to write back?
Yeah, I mean, I don't know whether it's relevant or not, but basically, I mean, I've felt that the documentation for most of these APIs are not, I mean, it's not like, in place, right? So we have faced a lot of problems, right? I mean, which we have, figured out by doing trial and errors, right? I mean, so basically when you try to do something, right, it kind of fails. And if you try to Google it, or if you try to kind of look at the documentation, you'll not find something, right? So we have to kind of figure out ways to kind of solve that problem. For instance, I'll tell you one problem that we faced with intercom. We are trying to update the data and it was not working, right? We were kind of getting stuck, right? And then after a while, we realized that we are compressing the request, right? And the server doesn't really accept, requests which are compressed, which is kind of unusual because most of the servers do take that, right? But it is not documented or something, right? So we kind of took a lot of time to kind of debug such issues, right? So every time you write a connector, there are always these kind of gochas, and it is mostly because of the fact that the APIs are not really well documented, right? I mean, I'm not sure if this is relevant to a question or not, but this is something which we have figured out.
Yeah, and I guess have you identified any sort of like strategies or patterns that help you overcome, let's say specifically around API rate limits?
Yeah, so I mean, there is no like one way to solve the problem for all the connectors, right? For every connector, you have to figure out what is the rate limit and be. For instance, in case of Salesforce, right, they are saying so you can make only 50,000 API calls, 15,000 API calls in 24 hours, right? So now, I mean, we know that. I mean, we know the documentation. We have read the documentation. We know that. So now we have to handle it, right? I mean, and this is not in our control also, right? I mean, other clients might also be calling it, right? So in that case, what we do is, when this happens, right, we kind of pause our pipelines and then do it after 24 hours, right? But this is not the same for every connector, right? So these kind of things, right, rate limits and all those things needs to be handled differently for every connector. But our framework has ways to kind of do all these retries, right? If you want to do retries, you just have to figure out what to do. But to do that in our framework is kind of pretty straightforward.
Cool, thanks.
Yeah, anybody else?
Yeah, Arun, I think you've already answered because you mostly depend on the APIs of the other systems. So we had I've faced this issue a couple of times with different connectors where there's a data type or a truncation issue. Like Salesforce itself has like two sorts of ways where it stores the data. One is like the display, like for example, when we talk about the money, there is in the display part of it, it will show only two numbers after decimal. However, in the storage, it will store all the numbers. So from the monetary perspective, it can be really critical. So do you have you faced certain such issues in, Castled, or have you figured out a way to, solve these sort of issues?
You're talking about decimal precision, is it?
Decimal, I mean, there could be decimal precision. Mostly problems occurs in decimal precisions when we talk about truncations. Yeah.
Yeah, I mean, we did. I remember there was an issue in that. And again, there's no generic answer to that, right? So it depends on connector to connector, right? So we do an exhaustive testing. We try to make sure that the data is coming there. Then we realize, okay, so this is not working and it's not documented, right? So let's try something else, right? And then, so I mean, that is one of the major problems that we have seen is that without proper documentation, these things can be slightly tricky. And to answer the question, decimal precision, I think we have seen it in some connector. I don't really remember which one, right? So we have to kind of do something to kind of solve that once. Yeah.
Yeah, makes sense. Thanks.
And Arun, I think the APIs also keep changing, right? You don't know when the contract changes, right? So
Yeah,
there has to be somebody who has to maintain these integrations.
Correct.
Like, let's say if you build it in-house, yeah.
Yeah, correct.
Right. If no one else has any other questions, I'm conscious it's probably late for you, Franklin. I think you mentioned earlier it was a bit late for you.
Yeah, sure.
Oh, that's all right.
I'll hand it over to Franklin. Yeah.
Thanks.
Let me share my screen. Can you guys see my screen? Okay, I think we can get started with the demo. So for this demo, we can think about a hypothetical, a B2B SaaS company, and let's assume that the sales team in this company is actually exploring upselling opportunities with its existing set of customers, right? And so currently the sales team is using HubSpot as the CRM, and the company is using Snowflake as their data warehouse, right? And for example, so we are currently looking at their data warehouse hosted in Snowflake. So we have a test database, and within the test database, we can see there are two tables. One is contacts, and one there is subscription. So contacts is a list of customer contacts for the company, and we can take a look at the contents of this table. So let me run select star from contacts. So I hope the font is big enough for you guys to see. So yeah, so if you look at the columns, right, so you can see the name of the business, the category. So these are all the customers of this B2B SaaS company, right? And the contact name for that business, the email and everything. And similarly, if you look at the subscription table, I'll run select start from subscriptions. So this has subscription details about each account, right? So the first row, the first column is the email associated with the account. Then you have usage tier, and then you have a feature. So this company is offering, let's assume it's offering 3 features, A, B, and C. So if a user is in a free tier, so what that means is he can use one feature for a limited amount of time. And if he's using a pro feature, he can use one feature for an extended period of time. And if he's using enterprise, he's on enterprise tier, so he has access to all the features, right? So from a sales point of view, right? So what is interesting to them if you think about upselling, right? So whoever is in free or pro tier, he can be a target can be, sales team can use them as a so there's a good chance that people who are in free or pro tier is going to upgrade in some time down the line, right? So we can write a SQL query to kind of extract the users who actually fit this criteria, right? So basically, so what I have done is actually, I wrote a SQL join query, which does that, just join the two tables using email as the primary key, and and exclude the rows or exclude the users who are on enterprise tier. So for example, if we run this query, okay, so now we have 6 users who fit our criteria. Now sales team can go after these people, or they can they can have some kind of sales campaign targeted at these people, right? So in order for them to do that, this contact information has to be in HubSpot, which is the CRM that they use for their sales workflows, right? So how do we move this reliably to their HubSpot, right? So this is where Reverse ETL tool come in, right? So we can see how we can use Castle to create a reliable data pipeline to sync these contacts from Snowflake data warehouse to HubSpot. So I will switch to Castle tab. So I have already logged into Castle. So for example, if you are actually, if you don't have a Castle account, if you're trying to create one, you can start by going to castle.io, and you can just follow up the sign up process to create a new account. So I already have an account and I've logged in. So this is the logged in view of the Castle app. So in order to create a pipeline, so you can follow the pipeline create link in the welcome page. So I will click on that. So the first step is to create a source connection or a warehouse connection. So in this case, so our source is Snowflake data warehouse. So we can click on that. So currently we support all the 4 major data warehouses. So I'll select Snowflake. So I have already created, configured the Snowflake connection for the data warehouse that I'm demoing it for. So if, for example, if you are trying it out and if you are creating a new warehouse connection, so what you can do is you can click on create new warehouse button, and you can enter your warehouse credentials. So if you need more information on how to get these credentials, you can always, there is a link to our documentation. So you can click on that, and that has more details about how to get these credentials. So now going back to, so now we can select already the pre-configured warehouse connection. So the next step is to enter the query that will form the table and which will be used as the source table, right? So we will use the join query that we used earlier for that. So I paste that query, and so run query will help to see a preview of the query rows. So now you can see that so both the tables are the same. So once you verify that your query is running correctly, and so you see all the required columns, you can proceed to the next step. So now the next step is to create the destination connection or the app connection. That is, now you have to configure the app to which you are going to send this data, right? So in our case, we are going to use HubSpot. So again, I have configured HubSpot for this demo, and you can follow the create new app button to create a new connections for your specific account. So I will select the demo HubSpot account. So HubSpot internally has a bunch of objects. So and for this demo, we will be trying to sync customer contacts, right? So it has an inbuilt object type called contact. So we will be using that as the destination object. So whenever you are updating, so each row in the source table get converted into a contact object at the destination end, that is at the end of the HubSpot end. Okay, similarly, for sync mode, I will be using upsert as the sync mode. So what upsert means is that, so if the new record coming into HubSpot is an existing one, so it's going to update that record, and if the record coming from the source table is actually indeed a new record, it gets added to the contact list. So now we can move on to the next step. So now we have come to a page called a mapping page. So what we are doing here is we are mapping the columns from our source table in the data warehouse. So like whatever table that is will be materialized by our query, right? So we are mapping the columns from that table to fields in the destination object. So in our case, the destination object is a contact object in HubSpot. So warehouse column has a column called email, and we will map that to an email field in HubSpot contact object. So this email will be also a primary key. So what this means is that, so when we are trying to update these record into HubSpot objects, this email will be used as a lookup key. It's also called as a deduplication key. So this information is actually coming from HubSpot. So HubSpotting is telling us that, okay, so if you are going to update a contact object, so you have to use email as the primary key. So the first name from the table will be mapped to a first name field in the object. Similarly, last name from the table will be mapped to last name in the contact object. So usage tier and feature are, two custom attributes that I have created for this demo. If you look at, so I went to the, my HubSpot account, and I added 2 new fields for that contact called usage tier and feature. So I will map the usage tier from the table to the usage tier in the object. So why do you need this, right? So the thing is, like, when you are trying to do a sales campaign, right? So it's the more information or more context you have about the customer, the better it is, right? So the thing is, you will be able to personalize your, selling, make the, selling experience as personalized as possible. So this is the reason why it's good to have, the product usage metrics of the customers, or the subscription details, or the last feature used by the customer. All this information, you can bring into your sales CRM through this process. So now, once you're done with the mapping, you can click on continue. So next step is you can specify a name for your pipeline. And so we currently support 2 types of query mode. So this incremental means that so every sync will try to will figure out what is the delta from the last sync, and will only try to update that delta. And so I think most of the sync, most cases, incremental will be is the ideal way. So that way you can also keep the load on the system, keep the load on the system less. And similarly, if you want to ensure that every time you're syncing, you want to sync the entire table, so you can go with the full load option. And for frequency, we can go with the default frequency. So we can click on create pipeline. So this will create a new pipeline. And as a part of creating a new pipeline, it will kick off a new sync job. And this sync job will try to sync the records from our source table in the data warehouse. So we can see that the status has changed to completed, and it says that it has synced 6 records, right? So if you go back to Snowflake, we can see that this query in fact had 6 rows, right? Now we can go back to contacts. Yes, we can see that all these records have been already updated. So so along with the name, email, we can also see that feature in use and usage are also updated. So now that all this information is in Salesforce, right? So the sales team can go ahead with their sales campaign workflow or go after their sales lead, right? So another interesting thing is, so now we are using a table in the data warehouse as the source, right? So the thing is, these tables are constantly fed by ETL pipeline. So they are constantly changing, right? For example, the contact table that we see now won't be the, for example, in few hours, it might change, right? There might be new people signing in, right? So based on that, the contact table would change. So to kind of mimic that, I will just run a query to insert a new user into the contact table. So the customer name is called Buy More. Similarly, we update the subscription table for the same user. Now, if you run our join query again, we can see that there are 7 contacts here, right? So we have a new contact. And so the next time we run the sync job, right? So it should sync this new contact to HubSpot, right? So right now HubSpot has only 6 contacts. So we have actually configured this pipeline with a sync frequency of 1 hour. So we could wait for 1 hour, but I think for the sake of this demo, I will just do an instance sync by clicking on sync now. So it has triggered another sync. Let's wait for it to complete. Okay, so we can see that's completed, and interestingly, it has synced only just one record because that is the delta, right? Since last time we have synced. So let me refresh the page. Okay, now we can see that the new record has been updated in HubSpot. Yeah, I think that's all about the demo. So with that, we can open up for any questions.
Yeah,
very
I
much,
think this
Franklin.
was really awesome, Franklin. Yeah, one quick question I have is, I think Arun already answered that as of now, there's no support for CLI or Terraform, which is fine. And he mentioned that there would be probably gradually we should be able to push. My only maybe suggestion or maybe question would be mainly around secrets. Because normally the access is given through secrets manager, through a role or all those things. So having a person put in ID and password in a production grade system becomes really challenging thing to do. Yeah, so something I've like, yeah, I don't know whether you have this in the roadmap or you plan to support, but something I would say that would be good to have that if possible.
So,
yeah,
I don't. You want to take the question?
Yeah. I mean, so basically, how does Terraform help? I mean, we are not really aware of it, right? So, I mean, what is it that I understand your concern that you don't really want to put your secrets directly in a form in a production environment, right? But what is your suggestion, right? I mean, like, you're welcome to suggestions, right? How can we have?
So normally, I mean, different data warehouses may have different things, but let's take an example of Snowflake. So let's say, so normally what happens is somebody, a team who manages Snowflake may put, some sort of key pair or, ID password in a secrets manager so that they can rotate. We don't have to worry about, like, as a users of Snowflake, we don't have to worry about maintaining that or person putting in. So what we'll do is in infrastructure as a code, or maybe it could be CLI, Terraform is not supported. We go and IAM role is given access to that secrets manager. That IAM role would go and read that and publish that connection. So that can be a connection between, as you show, Snowflake and Marketo probably. So once that connection is established, so every that's sort of a data source connection. So there is no human intervention in between for reading the ID and password. While if we don't have that, some sort of code versioning, then a person would have to input an ID password. That may be a bit challenging.
Got it. So yeah, it makes sense, right? You're saying there will be some kind of a secret manager, and I mean, basically, you kind of give access to the secret manager from the console, and then we like Castle should be ideally able to read the secrets from the secret manager, and then the keys will be rotated on the secret manager, something like that, right? That's kind of yeah, makes sense. I mean, okay, so we'll definitely consider that. That's a really good suggestion, and thanks for that, Hamid.
If I can. I was just going to quickly extend on that and say, for me, I think there are actually sort of two issues in there. They're slightly different. And from a Terraform perspective, or being able to script something makes it easy to reproduce and do stuff in a controlled and a structured way. And also from a DevOps sort of perspective, being able to apply changes. And if you now say, we don't want all those new connectors, then you can roll back to a previous release using your versioning and that kind of stuff. So I think Terraform and a way of scripting the configuration process is really powerful. That's just another thought that comes to mind. And then as Harmeet identified, I think being able to manage security and credentials is a really important way. And it's going to be different for everyone. Some people will use AWS Secrets Manager, or some people use a Terraform Vault. Oh, it's not Terraform, sorry. Who are they called again? HashiCorp Vault, or another product. There's lots of them out there, or whatever, that do secrets management. So I think securely managing credentials and rotating them and that kind of stuff is another really, really common thing. It'd be great if there was a way to accommodate it. I don't know how, but
yeah. I mean, I think we'll definitely consider that, right? So we'll kind of evaluate this Terraform also once, and we'll see how we can do that, right? I mean, so okay, so I did kind of okay, even if you're self-hosting, this is applicable, right? I mean, this is a really valuable suggestion that we'll definitely take this into account. Anybody else? Any questions?
Did you have anything, Ryan, you wanted to jump in with?
No, nothing comes at this point in time. Don't want to take up all the air in the room.
Okay.
Hey, this is Jörg speaking. I would be interested in how you determine the delta. Are you looking at on a block level of the tables, or you just simply require a last modified date or whatsoever, or timestamp, or how do you identify new incoming records?
Got it. I mean, that's a really good question, right? So that's one of the key challenges of a reverse ETL solution, that how do you kind of figure out incoming changes, right? So what we do is, I mean, like you told, right, if you are using an updated timestamp, right, so that is totally not reliable, right? Because I mean, you know what is a transaction window in a data warehousing system, right? It can be hours, right? Or even like say 30 minutes, right? So now if you look at a timestamp which is generated by your data warehouse, it is always not going to be accurate, right? Can have, so if if we have done this in our previous organization once, and we have seen data loss up to millions of records, right? So we know that is not the right way to kind of fetch records, fetch deltas. So what we do is we kind of create a snapshot table on your data warehouse in our own custom schema, right? So we'll create a schema called Castled, right? And then we'll create a snapshot table where the output of that particular query will be kept, right? So I mean, we are keeping in a different schema so that you don't have to give us write access to any of your production schemas, right? You just give us read access to your production schemas, and we'll have write access to only our internal schema, right? So we keep the snapshot tables, right? And then we use that snapshot table to compare with the previous results on every run, right? So now, I mean, this is what is happening right now, but we are also kind of planning to do a major improvement, where instead of storing all the records of the query, we'll be storing some kind of a hash, right? Kind of a checksum, where we'll just say that this particular row ka checksum is this, right? And then when you're comparing, we'll just compare the checksum, right? So that is something which is like, we'll be doing pretty soon. But for our reverse ETL use case, right? I mean, we have benchmarked up to 100 million records, right? Even with the old format, right? It is actually pretty fast, right? So you'll be surprised that the delta computation takes like not more than 3 to 4 seconds, right? Even if you're like, computing with 100 million records. But if you go slightly more, right, 1 billion records, 10 billion records, right? So then this process might become slightly expensive. So we have figured that out. And so that is the reason why, for instance, I mean, normally if you're talking about systems like Salesforce and HubSpot, right, it will never have so much of data. For instance, Salesforce can store 10 GB of data, right? But we have customers, we are moving the data to say, Google PubSub, right? But there's no limit. You can move like hundreds, billions of rows of data, right? So there we have seen that if the delta computation can become a slight problem. So because of that, we are even thinking about keeping checksums instead of actual row values to compute deltas.
Okay, makes sense. Thanks.
Okay, thanks. Yeah, anybody else?
I actually did come up with a question in the end.
Yeah.
So when we're doing that write back operation, and apologies if it was on screen and I just didn't catch it, but is there any what metadata is available to write back? So I'm thinking things like a run ID or some sort of timestamp information, so that when I do go look at this data that has been written now to my operational data store, I can then perhaps trace it back to, okay, this data came from this run, sort of to handle the concerns of lineage.
Yeah. Okay. So yeah. So that's an interesting question, right? So so currently we don't really have a lineage. Currently we cannot really figure out where the data is coming from, right? But I think we'll definitely consider adding that, right? Some kind of a way to trace it back to the source, right? That's what you're talking about, right? Yeah. So that's a really good
certainly.
point, right? I mean, we'll definitely take that in. Yeah.
Tracing it back to the source, and also like if there was an issue with a particular run, being able to identify which records have been impacted.
Okay. So that kind of information is not supported right now, but we'll definitely support lineage. Right? I mean, that's a really good point, right? I mean, we'll definitely consider that.
Thank you.
Anybody else have any questions?
Yeah, Arun, I see there are some questions in the chat. Kunal Tiwari has asked, how do you go about new integrations into a tool such as Marketo, etc.? So is there any way to use scripts to write custom code where integration is not supported?
Got it, right? So basically, I'll be going through in that next segment how we can write a new connector, right? I mean, that's the last part of the talk, right? Where I'll be explaining how we can write a new custom connector. It's kind of pretty straightforward, right? So now there is one more thing that I want to tell you, right? If for instance, if a particular integration is not supported, we also have REST API as one of our destinations, right? So with REST APIs, what you can do is, right, if you figured out what is a REST API to call, you can just put in the URL, right? You can put the headers, right? You can put the API keys in the REST API integration. And then ideally you should be able to support any integration out of the box, right? Even if it is not supported natively, but I think maybe you don't have to go there, right? It's extremely easy to write a new connector, right? Like I mentioned earlier, I don't know, like if it takes more than a day to write a new connector, then I'll be like really surprised, right? So that's how easy we have made our framework, right? But I'll be going through that in the next session.
Yeah, and we also support destinations like Kafka and Google PubSub, right? So where you can basically write your own consumer and do anything that you want.
Correct. I mean, we write it to those guys as well. So if you want to kind of, I mean, if you're okay with writing a consumer on yourself, but you can do that. But you have REST API as well, right? You just have to figure out the API, read the documentation, figure out the API, put in there, right? It is not, I mean, I don't think it is kind of extremely optimized to do that, but it will work for like 99% of the cases as well, right? But I would still prefer writing a new connector is kind of the right way, and it is kind of pretty easy, right? Like I can explain in the next segment, right? So that's what I would prefer any day.
Okay.
Cool. I think that might be a good segue to jump into the next session. I'm just a bit conscious of time as well. So, if you're ready to hand back over to Arun.
I'll stop sharing.
Sure. Sure. So I know that it is getting late for most of you, right? So I just quickly try to wrap this up, right? So these are open source repo, right? I mean, if you see, these are open source repo, and there are different modules, like commons, connectors, container, Javas, right? So the connectors is the module where all your connector specific logic is. The rest of that is like just framework, right? And which these are Jarvis, a task manager, container is a core which contains everything, right? So if you go to connectors, right, there is this module in apps, right? There's something called connectors, right? This is where you can see all your destination connectors, right? So if you want to write a new connector, right, I can just explain, say in case of Kafka, right? I mean, if you have to write a new Kafka connector, so basically you just have to implement two interfaces. That's all, right? If you see here, this is like I just have to write 5 files, right? And out of this is actually pretty nothing, right? Almost all the files are like pretty small, right? So this is what you have to kind of do to write a new connector, right? I'll quickly explain the different things you have to do. First is something called an app config, right? So app config contains, like, I think you have seen how Franklin configured HubSpot, right? So you have to give some kind of connection parameters, which kind of decides how you can connect to your destination, right? In case of Kafka, I think all of you guys know that's a bootstrap service where you have to put your host name and host name and IP in this particular format, right? You have to give it for a particular column, or I mean, you can even give it for one instance, right? So you just have to give that, right? That is one of the connection parameters which is required to connect to Kafka, right? So now the other key feature in Castled is something called a Castled form language, right? So you would have seen all these forms, right? When you have to configure Snowflake, right? So these forms are, obviously we have our UIs on React, right? But we don't really want, in case of reverse ETL, some of these forms can be extremely complex. Some of them can be conditional forms, right? You might want to put radio box, you might want to check box, right? So the forms are not that straightforward, right? But we don't want you to kind of, have any kind of expertise on React to build a connector, right? For that, what we have done is we have built something called a Castled form language, right? So this is your config object, right? You just have to put an annotation here saying ki this is the title of the form, right? Whether it should be a text box or it should be a drop down, or it should be a radio group, or it should be a JSON file. If you want to upload a file, right, you can just put it here. Right? You just write an annotation on top of the fields, the config form fields, and it will automatically generate that the UI for you. Like, you don't have to worry about this config object anyway. You have to write, and you just have to write a set of annotations, and that will create the UI for you, right? So app config contains your connection parameters, which is required for you to connect to your destination app, right? Similar to that, there is one more config called app sync config, right? What it contains is, right, you would have seen Franklin selecting HubSpot object, right? HubSpot object, and what is the distinct mode, right? Whether it's upsert, insert, right? So these are additional parameters which you need to configure while you're creating a pipeline, right? So you already defined your connection parameters. These are additional parameters. So that is app sync config. This is displayed while you're creating the pipeline before the mapping page, right? This also, you already have a config object. You just define a few annotations, right? Like one annotation per field, and then the UI will be automatically generated for you, right? So these are two configs that you have to define, which is mostly like 2-3 lines of code, right? You have to write while writing a new connector, right? And then you will have to write two interfaces. One is something called an external app connector, and it contains methods, which is again required to kind of create a data pipeline, right? For instance, so in case of Kafka, right, there's Kafka connector, right? So you can say get all objects, right? So you want to figure out the topics, you want to list down the topics which is available in that Kafka so that the user can select it, right? So there is a get all objects method where you can, use this Kafka admin client and get the list of all the topics, right? So that is one example. Right now you kind of put in some config, right? You put the Bootstrap servers, right? You want to validate, you want to show it in the UI whether this config is right or not, right? So there is a method called validate app config, right? So whenever you click on submit, it'll come here, and then you can like throw whatever the relevant exceptions. If, for instance, it doesn't have any access, right, or the host name is wrong, right, you can throw you can validate your app config here, right? And the other example is, you suppose you want to get the destination schema, right? In case of the demo, you would have seen Franklin selected HubSpot, right? And then the mapping page, it showed all the fields, right? So here you can, there's a method in which you can return the app schema of the destination, right? Mostly it is like 2-3 APIs that you have to write to kind of get some data, which is required in creating a pipeline, right? And then there's just one more interface that you have to implement, which is your main interface, which is a data sync, right? So this mainly contains a one object, right, which is like the sync records, right? So the framework will give you something called a data sync request, right? It contains all the information which is required for you to make the API call and sync the data to your destination. And the major one is your message input stream, right? So basically, this is an input stream of records, right, which you can call repeatedly to get all the records from the source, right? And the framework will take care of giving you all the records, right? For instance, in case of Kafka data sync, right, you can say that there's a while loop in which I'm just calling all the records, and the records which are being fetched, right, and it is just being published to Kafka, right? I'm just doing Kafka publish message, right? And the other thing is that if this fails for some reason, right, when I try to publish and fails for some reason, then this data sync request also has something called an error output stream, right? What you can do is you can just write the failed record and the error to the error output stream, and the framework will take care of, pushing the data back to your snapshot table, making sure that the failed record will be run when you run the next time. It will also kind of create what you call as a failed error reports, right, which you can download as a CSV, right? But from this point of view, it is just one line, right? You just have to write the failed record back to the error output stream, and the framework will take care of everything, right? So now if you see here, it is probably around, writing a connector is probably around 100 lines of code, right? Nothing more than that, right? So that is how we have, kind of built in such a way that it's very easy for you to write a new character. And that is why I said, if you want to write a new character, I would rather prefer that rather than using REST API. Yeah, I think that's about it. You guys have any questions?
Nothing else from me on the top of my head, but thanks very much for coming and presenting and sharing with us. It's been really fantastic to learn a bit about it. We'll post the recording of this session against the Meetup page. And for anyone else, we'll post the links to the repo and stuff in there so you can go and have a look at it. And I think that's the code that you're showing us on the screen here now. So if anyone wants to jump in and have a look at it, have a look at building connectors for their own custom in-house systems or whatever you're using, then you can have a look at how you might be able to do that in here. And it looks really good. Looks like a great framework that you've set up for everyone. So thank you very much. I might quickly flip over to here, if I can. And thank you guys for presenting. And we'll jump in and have a quick session on the Data Engineering Melbourne Marketplace. So this is a great opportunity. We'll give everyone, it's like an open mic, so we'll give everyone 60 seconds. So if you're looking for a job or a role in data engineering or something, then feel free to introduce yourself and try and make contact with some people. Or if you're looking for some people to come and work on a data engineering project, then again, feel free to unmute yourself and introduce yourself and tell people, what you're looking for from people to come and help you. Also want to extend the opportunity as well. If anyone's got a favorite project or you're working on something open source or whatever, and you want to tell people about it, if you're making some tools or anything, then feel free to share with the community. And yeah, so we'll give everyone an opportunity to unmute yourself and share.
Hi, my name is Tamer, and I'm new to the data science field. Actually, I've spent my experience, or since I've graduated, I had graduated from engineering, from Faculty of Engineering as an electrical engineer, and I've been working in building services for several years, and then I decided to follow my passion. I recently finished a bootcamp from Monash University about data analytics, and I'm interested. Really, I'm looking for a job. I'm really excited and really interested to start in this field.
Oh, fantastic! Thanks for sharing, Tamer.
Thank you.
And if anyone wants to get in touch with you, do you have a LinkedIn profile or something, or would you have an email address you could share perhaps in the channel? And if anyone wants to reach out, they might have some opportunities they could talk to you about.
No worries, no worries. Thank you so much.
Thank you. Anybody else?
I'll go.
Sure.
Give me a minute. Okay, my video is not starting here. Anyway,
okay. Some people are shy and don't want to use their camera. That's fine as well.
No, I'm not. I'm legit. Like the video is just not starting.
Sure.
Anyway, my name is Cash. I am a graduate student at University of Melbourne. I did my undergrad in data science, and I also worked as a data scientist for a telco company. The reason why I'm coming to these talks is that I figured that whilst I was working, I felt like I didn't know a lot of data engineering concepts. I was mainly taught like the theoretical stuff, like modeling and stuff, but not really the engineering principles. So I'm just here to learn about all the ETL and stuff, the new data stack and stuff. So it's just here for a purely educational purpose. The one thing that I do want to plug is that I'm actually also part of the data science student society of University of Melbourne. We have both postgrad and undergrad people. So if anyone wants to reach out to the society to have some engagement or something like that, I would love to share my contacts. But yeah, that's all I wanted to say really. thank you guys, and it was a really nice talk. I think I learned quite a few new concepts. Looking forward to more new stuff. Thank you.
Great, that's fantastic. Thanks for coming along. And likewise, if you have any contact information or whatever, some way
Sure.
people can reach out if there's a website or anything,
Yeah,
then feel free to put that in the chat and stuff, or you can post stuff on the Meetup page as well. It'll be
Alrighty.
public, but so consider what you're publishing there, but
Definitely.
encourage you to share stuff on there as well.
Alrighty, thank you guys.
Thanks. Okay. If no one else is putting the hand up, we'll sort of close this off here, but we'll say thank you very much to ThoughtWorks. ThoughtWorks helped provide the Zoom call and everything for this, and help support Hamid and the organisers and stuff to run Data Engineering Melbourne. So thank you very much to ThoughtWorks as always. The next meetup is penciled in for the 24th of February. We've got a fantastic talk which is being put together at the moment. We won't spoil the surprise and tell you what it is yet, but keep an eye on the Meetup page. It'll be coming out Thursday, 24th of Feb. And there's some contact details as well there. So if you've got a great topic you want to share, or something, or you're interested in participating or getting involved in Data Engineering Melbourne, then feel free to reach out to Harmeet or myself. Our contact details are on the page. And thanks everyone for coming along, and a huge thank you to our special guests, Manish, Arun and Franklin, to come and talk to us about Castled and tell us a bit about how it works and what it does and stuff. Was fantastic. So thank you very much.
Thanks a lot, Tim, for organizing this talk. Really glad to being a part of it. Thanks a lot.
Thank you everyone. It was awesome talking. Yeah, thanks.